Hello everyone, I'm Idrissa again. Let's talk about lesson 2. Today we're going to talk about the complex number I and the exponent rules. So any quadratic equation in the form ax squared plus bx plus c equal to 0 when a is different than 0 can be solved in R, except this example x squared plus 1 equal to 0, which means the b part equal to 0 right here. So when we try to solve this equation in R, let's see, we have to adding negative 1 in both sides. So when you are adding negative 1 in both sides, you will end up by x squared equals to minus 1. That implies that when you apply the radical in both sides, you will find x equal to plus or minus negative 1, radical negative 1, which is not belong to the R. So now we have to find another way to solve this equation. So let's consider a complex number I, such as that I equals to radical of minus 1. So if I took the square in both sides according to the equal sign, so I'm going to have I squared equal to minus 1. So this little formula is very, very powerful in a complex world. So example, I may say simplify the following expression. 1 I squared, I to the third. How can I break down I to the third? Since I to the third can be right like I squared times I, so we know I squared equals to minus 1. So I will substitute that by minus 1 times the I. So I to the third equals minus I. What about the I to the fifth? Well, I can break down the I to the fifth to I times 4, I to the power 4 times I. So I can break the 4 as I squared all squared 2. So times the I. Since I squared equals to minus 1, I'm going to have minus 1 to the power times the I. Finally, I to the fifth equals to I. What about I to the 50? So we can divide the 50 by 2. 50 by 2 is 25. So I can have I squared to the power 25. So I squared equals to minus 1. So minus 1 to the power 25, that equals to minus 1. Meaning that you multiply negative 1 by itself 25 times. Now what about I to the 63? Well, I to the 63, I can break it down to I to the 62 times the I. Then I can divide the 62 by 2, which is I squared to the power 31 times the I. Now we have minus 1 to the power 31 times the I. Minus 1 to the power 31 meaning that you multiply minus 1 by itself 31 times, which is minus 1 times the I. You end up by minus I. Now a little complicate. We have 2I squared times 3I to the 4. Well, 2I squared equals to minus 1 according to the formula right there. I will substitute that by his value. And then 3, I can break down I to the 4 to the I to the power 2 to the power 2. I to the power 2 is negative 1. Negative 1 to the power 2 is positive 1. Positive 1 times 3 is 3. So I'm going to have negative 2 times positive 3. The answer is minus 6. So this expression equals to minus 6. All right. So now, let's talk about the exponent rules since we use them. So anytime you have x to the power 0, anything to the power 0 equal to 1. Since we have to make sure that the x must be different than 0. If the x equal to 0, we have 0 to the power 0, that's undefined. Example, negative 2 to the power 0 is 1. 100 to the power 0 is 1. 1/2 to the power 0 is 1. Anything to the power 0 equals to 1. And the other rule for the products, if I have x to the power a times x to the power b, you keep the base and then you add the exponent. Example, I have 2 to the power 5 times 2 to the power 3. You keep the base. Now you're adding 3 plus 5, that's 8. Now if you divide, you subtract the exponent. I have x to the power a divided by x to the power b, that's equal to x minus b. X to the power a minus b. Example, I have 3 to the power 6 over 3 to the power 2, you keep the 3, you subtract the 6 by 2, you end up by 4. So now if you have exponent over exponent, like x to the power a to the power b, then you multiply. Remember, here is adding. When you have the base side by side, you add. But if you have exponent over exponent, you have to multiply them. Example, 5 to the power 2 to the power 6, you keep the base, 2 times 6 is 12. What about if you have two different bases when you subtract, when you divide them? So you share the exponent at that moment. X divided by y all to the power b, that's going to be x to the power b over y to the power b. Example, if I have 3/5 all to the power 2, you share the power between, so that would be 3 to the power 2 over 5 to the power 2. 3 to the power 2 is 3 times 3, which is 9. 5 power 2 is 5 times 5, which is 25. Same if I have two different bases that are the product, I will share the exponent. X times y, all exponent b, that equals to x exponent b times y exponent b. Example, 3x all to the power 2. You share the exponent, so it's going to be 3 to the power 2, and then x to the power 2. 3 to the power 2 is 9, so the answer is 9x squared. But if you have a negative exponent, how to change it to a positive? You go 1 over the same guy, but without the negative sign. Example, I have 5 to the power minus 2. I will go 1 over the same guy without the minus sign. It's going to be 5 to the power 2, which is 1 over 25 to the power. So I hope this little video become very helpful for you to know the rule of the exponent. I will see you next time. Bye.